It is the Heltec BMS HT-RT01. The internal resistance tester. High resolution, high precision, automatic switching, double 5-digit display, widespread application, computer online analysis, high anti-interference. That all sounds amazing, but it is a Heltec product. We have tested quite a few Heltec products here. Guys, welcome back to the Off-Grid Garage here in sunny hot Australia. It's a late night show. We are back to working late night in the garage because it is hot again during the day. And to kick off our new project, we want to have a look at the Heltec HT-RT01, the internal resistance tester, the high precision internal resistance tester. Look at this. This is a big box. Oh, guys, without further ado, let's get right into it. Manual. Warning from ooh. Look at this. Oh, I like these rubber buttons here. USB port, display, positive, negative, double connector, cursor buttons, power button, power supply. And here are the technical specifications. Measurement parameters, AC resistance, DC voltage, 0 to 200 ohms, 0 to positive negative 100 volt DC. Resolution 0.001 milliohms or 1 millivolt. Precision 0.5% for resistance and voltage. Test pace 5 times a second. Range automatic switching. Measuring input balanced system, whatever that means. Measuring probe LCR Kelvin 4-wire clamp. Oh, they feel good. Measuring probes, a USB suicide cable, European Shuko power cable. What the hell is that? Well, I can't tell you, What is that? Oh, that is a little test bench. Ooh, I like this one here. Little test bench. Oh, it says here 18650 and 32700. You can adjust the distance depending on what kind of batteries you are measuring. Ooh, that's pretty cool. Okay, let's get this one connected. Ooh, nice display, which you cannot see at all. You can't see it. There, it's green. And the resolution looks good. You can't see shit. Oh my god. It's not working on the camera. It's a good start. I am supposed to show you something if the display doesn't show up in the camera. Ah. Nah. Ah, god, jeez. Let me get the other camera. I'll be back. Oh yeah, that actually works. Just. And we can see the resistance measurement at the top and the voltage measurement at the bottom. We've got an auto set for both measurements. And I think we can change this by pressing the voltage button here to 2 volts, 20, 100 and auto again. We can do the same with the resistance button. 20 milliohms, 200 milliohms, 2 ohms, 20 ohms, 200 ohms, and then it goes back to auto. So I'm not sure why you would change this actually, because on auto it does it automatically, but there's an option. The top button gets you back into the menu, and there's no up again. You only can go down in the menu with this button. If you press this one again, it doesn't do anything. So you have to go all the way down to number 8, quit, and then hit the yellow button, enter, to get out again. Okay, so that's pretty much everything we have. So we've got only a few options here in this menu. It's not too busy actually. So we can calibrate the resistance measurement. We can also do the same with the voltage measurement. Number 3 is reserved. It doesn't do anything. Reserved on off. There's a factory reset. There's an about. We can change the language. We can activate the USB port and we can quit the menu again. This is pretty much everything you can do with these 4 buttons. I was a bit excited about the possible functionality of all these buttons here, but it's really only that, so it is very, very basic stuff. Language, serial port, We turn the port on. Yeah, yeah, we've got a little USB symbol now there, so that's obviously activated now. And I'll tell you more about this function soon. Okay, let's get a battery and measure something. Okay, let's use this little test bench. Okay, positive goes to the positive, obviously. Oh, wow, that is firm. Okay, you need a bit of force to get these connectors in. That's probably a good thing. And then we need 18650 cells here. And have a look. There's a spring mechanism in here. Alright, and now it's measuring already. Oh, you can't see that. Alright, here's the display for it. So, this battery has 60 milliohms and 3.65 volts. It's an 18650 cell. I'll just test another one. This one has 61. It's really hard to read, even for me. 61 milliohms and 3.8 volts. And the third one, I'm measuring this one the other way around. See what's happening. We've got 0.1499 ohms, which is 150 milliohms, and negative 4 volts. This one is almost fully charged, obviously. I'll just turn it around and try again. Yeah, this one has a very high resistance, 150 milliohms. Wow. This been tested? Ah, yeah, this one tested only 764 milliampere hours out of potentially. It's obviously a faulty cell with a very high internal resistance. So good, this thing works. So let's disconnect. This is really hard. And plug in our test probes and measure a prismatic lithium iron phosphate battery. Positive, negative. What? What? Really? I can't read the display anymore. So this is 0.38 milliohms and 3.35 volts. But look at this. Guys, they made these cables so short you can't even measure a prismatic cell. Look at this. This is the full length, and these probes are already so long. If you wanna measure that, it is just not long enough, and then you can't read the display anymore because it's hidden behind the actual cell. I'm not kidding you guys. I can't read the display. I can't read it. I need to. Oh, come on. Is that how it's supposed to work? 0.5 milliohms now. Oh my god. Really? Has nobody at Heltec tested this before and realized the cables are a bit short if you want to measure prismatic cells? Just wait. Yeah guys, remember this cell here? This is our test cell where we have tested so many different settings and tried all kinds of charge and discharge methods. This was my first lithium iron phosphate cell I ever bought, just for testing purposes. 100 ampere hours. It went through a lot of cycles already. Okay, and if you want to measure this one here, it is just, come on here. I just want to measure this cell. I can't read it. The display is behind the battery. I think this is the only possible solution, to have it on a tilt angle like this. But then when you want to measure the next battery, then you have to drag it behind you on the bench, and you go to the third one and you drag the whole thing with you. This is like 330 millimeters long. Okay, this is totally impractical. Precautions for use. during the measurement process. Do not use a mobile phone near the instrument to prevent the radio frequency signal radiation of the mobile phone from interfering with the instrument and causing error in work. So I cannot even have my... What? During the test, keep the test clips parallel to reduce the influence of eddy current and improve the test accuracy. So they want us to actually have these ones here like straight on the terminals, but then I cannot read the display anymore because... Okay, so I discussed the purpose of this device before they sent it over here for me to have a look at it. And I said, well, we already have an internal resistance tester, and this is actually a good device. You know, this is like portable, it has a battery, and it has actually fairly long cables here, so you can measure the battery and read the display at the same time. How amazing is that? Well, this one is a high precision internal resistance tester. This one is not precise. Does it say anything? I'll put it here on the screen, what it says online. And I told him, well, this is not really practical because it needs a 230 volt connection cable. What if my battery is over there, the Frankenstein battery? If I want to measure the internal resistance, I have to get an extension cable first to connect this device, bring it over there, and then drag the whole box behind me across all the terminals because the cables are so short. Is that how it works? And they said, well, this one here stays on your workbench and you have your batteries in front of it and test one battery after another. You measure, you measure, you measure, you measure. And this tester gives all the data via the USB cable to your computer. It puts all the information into a list for you, and you can also set a threshold for voltage and internal resistance. If one of your batteries you are testing is getting out of these specifications, it's been marked red in the list. Yeah. So this device is not so much focused on us do-it-yourself people who are building their own battery. It is more for battery builders or for battery testers, for battery manufacturers, in an environment where you have a lot of battery cells on your workbench and you want to test them one after another quickly with this device. And luckily we have a few boxes there full of batteries. Yeah, they just arrived 2, 3, maybe 4 weeks ago. I don't know. So in the next video we want to see how practical this device... So in the next video we want to actually see how practical is this device here when you get the delivery of 4 or 5 boxes with batteries. How quickly can you get all the data and put this in a list on your computer? So I really like this idea, but guys, these cables are too short. Maybe this is why you have to keep the box where the tester came in, and you have to elevate this one a bit. Yeah, that works a bit better. And it says here, please contact Heltec BMS to download the driver software and installation video first. Firstly, turn on the USB port. We've done this already. Connect the tester, open the installed software, and then happy testing. There's no website address in here or a QR code where you can download the software. No, you have to get in contact with Heltec in China to get a link to download the software. It is not on the website www.heltecbms/downloads. No, it's not. You have to contact them first to get the link. Okay, let's connect one USB to the data port of the tester. It is really hard to get all these connectors in. And the other side obviously goes into your computer. And the cable here is not very long. And then we obviously start the software called Battery Tester. I wouldn't have come up with a better icon than a skier for a battery tester. I mean, it's perfect. Okay, obviously we have to connect to COM12. Open the port. Yes, we've got the communication. What? What's going on here? Okay, let me have a quick look what's going on here. Select press the mouse to open the serial in real time. Some voltage can be set in the batteries, can be by setting the values to... Okay, so you want to filter lithium... I'm not sure why we already have a resistance here while the display actually shows OL. restart the device. Okay, we've got 0 now. Now turn it back on. Okay, everything is 0 now. Okay, that's fine. Okay, perfect, perfect. Okay, name, Andy. Date, 05/02/2024. Yep, that is fine. Add line. Oh, what does that mean? Alarm setup. Internal resistance, 5 milliohms to 10 milliohms. If we are out of that, we should get an alarm. And the voltage is 3.25 to 3.28. Sound source, pass NG, doo-doo. This is a different alarm than Dada from Zepplos. And the last sentence says, set the torque index of the electric screwdriver to 3 and lock the screws until we hear the sound of Dada. Really, Dada? What does it mean, Dada? That is insane. I like it. I'm really looking forward to build this battery. Dada. Insane. That is incredible. Oh yeah, I don't know what this means. Acquiring frequency 0.5. Group mode. This is not explained in the manual what this all means. Well, we will find out. Clear data. Fix clear. Okay, let's measure our first cell. There's no data. Why is there no data coming through? I've got the numbers on the display here on the tester, but there's nothing in the computer software. Why is that? And auto voltage as well, as it says on the display here on the computer. Ah, you know what? The USB connection. I can't show you the display here. Oh shit, eh? The cable is too short to the computer. There's no USB symbol here. Language serial port. Enter. On. Enter. There it is. Holy shit! What the heck is happening now? Alarm! That's the computer. Why is it doing this? It says NG. What the heck is it doing? Stop it! Pass NG. Okay, acquiring frequency every 5 seconds. Open. Does it say Andy? Ah, NG. 2000 to 3000 milliohms. Why is it NG? Ah, because I'm still... Shut up! Why is it showing 0.24? Shut the hell up now. Why is it measuring 0.24 ohms? That would be 240 milliohms. What do we actually have with this battery? We have got 0.25 milliohms. This is not 0.25 milliohms. The data on the display does not match the data on the screen. The voltage, I think it's accurate. I have to turn it back on. I think we can quiet. Yeah, shut up. Open. So this is exactly again 0.246 milliohms. This is totally wrong. Voltage is correct, but the resistance is completely wrong. So you can see the resistance on the computer screen, and down here you can see the resistance on the display of the tester. Yeah, it is but this is 0.235 milliohms on the tester, and up there it is 235 milliohms. This is like factor 1000 off. Oh wow. Between 200 milliohms and 300 milliohms. Oh no, I can't get a pass. This is ridiculous. This is not working at all. Sorry Heltec, but this product is garbage. See how it says ohms here, and here it says milliohms. So what should I put in now? So we should be in this range when I measure this battery. Ah, we get a pass. Yay, we get a pass. Okay, so it is doing this every 5 seconds automatically. What if I need longer than 5 seconds to change my batteries? Then you can zoom in and out here. Obviously it makes you a graph and shows you the voltage and resistance. So if I set this one here to every 10 seconds. So I've got 10 seconds from measuring one battery to the next one. 10 seconds, right? Look when NG appears here on the screen and then count 10 seconds. There it is. 1, 2, 3, 4, 5, 6. 6 seconds and it comes back. Even I've set it to 10 seconds. And it creates a log entry every 6 seconds now. Watch this. Okay, we've got a pass. See, I've got a voltage reading down there. Another one. Again, I'm taking the probes off. And it is still measuring some voltage and resistance, even the probes are off. Okay, anyway, we close this one here and then we save the data. We can save this as a text file. Okay, being saved. Okay, it's the same. Gives you the date, the time, obviously the resistance and the voltage. I don't quite understand how this works. So if I have 16 batteries here on my workbench and I want to measure them all one after another with this software here, I have to change my probe every 6 seconds, the latest, to the next one, to the next one, to the next one. But what if my probes are not properly connected to the terminals of the battery and it's showing some mismatched or wrong numbers on the display? Yeah, I have to adjust my probes and put them on different locations on the terminal, and then I've got a clear and clean reading. But this software has already jumped 3 batteries further, and there's no button or something on the probe where you can say, okay, this is my measurement, next battery, I'm adjusting everything, that looks good, measurement. No, it does it per timer, which is not even working correctly. Let me connect again. So let's clear the data. Open it again. Measure the first battery. Yeah, I would say, okay, that's a good reading. Okay, go to the next one. That's a bad reading. Hang on. Need to adjust the probes here. Yep, that's a good reading. Okay, next one. Measure from this side. Yep, good reading. And number 4 comes from here to here. No, hang on. I need to adjust. Yep, good reading. Okay, 4 batteries measured. Close this one. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 measurements in the list now as our data. And which of these data is actually my proper battery measurement? Okay, so in the next test I want to compare the reading of the high precision internal resistance tester to the reading of the not so precise internal resistance tester. Okay, we measure this one first. Okay, 0.22 something milliohms, yeah, and 3.306 volts. Okay, let's test this one. Positive, negative. Whoa, 0.33 milliohms and 3.295 volts. Okay, let me try again. Different position on the terminal. So 0.33 milliohms and 3.295 volts. It's the same. All right, guys, I don't know. It looks like this product is not ready for the market. Maybe it is a prototype or something and they want me to test it and give them my opinion. Well, I guess here it comes. This is the verdict about the Heltec BMS HT-RT01 Internal, no, high resolution, high precision internal resistance tester. Really nice looking case, rubbery buttons, It's a 4-wire measurement, so they're measuring the voltage and the current separately. The display is not really, I have to be in line with the display to read it. If I go a little bit higher, it's gone. It's an LCD display with background lights. Here it says it on the box, it does the 1 kilohertz AC current measurement. So that's the same method as the handheld internal resistance tester. It's a 1 kilohertz signal. That's what they all do, and also the battery manufacturers, they specify this 1 kilohertz signal or measurement in their technical data sheets. So the computer software is absolutely garbage. I really thought they're building a nice graph here, and we can trigger the actual measurement moment somehow. But this one works on a timer. So you have to change your probes every 10 seconds, which is in reality 6 seconds only, to the next battery and make sure the reading is correct. Yeah, especially with these 2-pin probes. See, they've got like a spring mechanism, and you need to make sure that all 4 of these pins have proper contact to your battery terminals. Otherwise the measurement is just garbage. It's not accurate. So it sometimes takes a while to find the right spot on the terminal. And I was expecting there's like a button or something here where you can say, okay, this is my reading now. I'm happy with that. But no, it's a timer. You have to be quick, you have to be precise. Otherwise you get a NG. Yeah, this is what I mean. And every time it does that, it creates a new data point already in the list. So you're ending up with a lot of garbage in your actual data list. Oh, come on, shut up. Yeah, and then I talked about the cable length already, which is not really practical unless you keep the box where the tester came in and use this as an elevated location for the tester itself, so you can actually reach the terminals on top of your battery. Otherwise, they are far too short. So, and then when you have your workbench full of 16 of these wonderful prismatic cells, for example, yeah, and you start measuring with the first one, and then go to the second one, to the third one, to the fourth one, and oh, this is my data cable, is a bit short now. Okay, let's unplug it. Yeah, and you go to all your other cells then. Do you drag this one behind you? How is this supposed to work? Maybe you need an ND2 for that. I am sitting here and measuring batteries, and ND2 is actually putting them in place and taking them away, put them somewhere else, get the next one in line within 6 seconds, because this is how much time the software gives you to measure one battery, and then it goes to the next one already. Come on. So honestly, Heltec, you're making wonderful and beautiful devices, but this one here, this is not thought through, it is not ready, the software is garbage, it's not working, and this is something not even a battery manufacturer can actually use. Unless you've got a conveyor belt and every 6 seconds a battery comes to your workbench to measure. The manual, is it recording? Yeah, it is recording. The manual gives you only a very basic understanding of how the device works. It doesn't give you any information about the software, how the software works, how to set up the monitor mode. There's a monitor mode and a group mode. No idea how this works. What are all these ones for? No idea. How is the graph supposed to be? No idea. What does add line mean? No idea. And then what I don't like at all is the actual need for a power supply. It's a 230 volt power supply needed to operate this device. But if I need the tester somewhere over there on my battery shelf here, how am I supposed to use that? Do they really want me to disconnect my fan and use it for the tester? No. The fan stays on. Then I would have no place to put this device here when I measure the batteries in my battery shelf. Can you imagine getting the probes in there somewhere where we've got such a tight space, and this one is just, I don't know what it's supposed to do. I know this is not the intention of this device, but this is how we use our internal resistance tester. Well, this one here is nice and small, and it comes in a full isolated plastic case. Metal, by the way. And I can easily put this on top of my batteries and have these super long measurement probes to reach all these terminals here of this battery. Of course, this one cannot be connected to a computer and doesn't submit any data to the computer, but as you have seen, the software is not working anyway. So there's no loss, there's no win. So I don't really know what to do with this device now, there are so many things which are not working, which are not thought through, which haven't been tested. Obviously nobody has looked at the manual either, because, well, at this point here, the text is overlapping the picture. Well, Heltec, are you not quality checking your manuals? No? No? Okay. And of course, this one is also more expensive than the small handheld internal resistance tester. Of course it is. I would really give this device here a 0 out of 5 frogs. We never had a device here with 0 frogs, but... And I'm not here to bash Heltec BMS. As I said, they're making wonderful, beautiful products, but this resistance tester is not one of them. I've tested quite a few Heltec products here on the channel, like the Heltec BMS, for example, in the top shelf battery, which I've recently replaced with a JBD BMS. Because the Heltec BMS had some software issues, didn't measure the current correctly, and also stops balancing after roughly half an hour or so. It just doesn't balance anymore. Even there's still a lot to balance, but it just stops. Or the 10 amp active balancer from Heltec we have tested here in the off-grid garage, which actually balanced only with 5 amps. Under the most optimal conditions, 5 amps only. I'll link this video down below. But they call it a 10 amp active balancer. Never seen 10 amps. So I'm really sorry to give this negative review here about the Heltec internal resistance tester, but I cannot see any advantages of using this device, either for us do-it-yourself people or for a company who builds batteries or a cell manufacturer. This is not the device, and certainly not the software you want to use for that. So guys, yeah, I guess if you are still here and watching this video, thank you so much for that. Thanks for all your great support here. For all these wonderful and beautiful people who have donated to the channel, buying me a cold beer. Thank you so much for that. And until the next video, guys, when we finally unpack the batteries here and do some more capacity testing, like in the good old days, do a bit of a review of these cells and the supplier, and then we finally want to put them into one of these cases here. Ooh, and I'm very keen to test and show you this new case. Until then, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye. Yeah, there it is.